Hello, my name is Daryl and welcome to the Sprinter Van Build series. Today I'm excited to present Chapter 11, which is the battery, inverter, and electrical cabinet or frame, whatever you want to call it. I'm probably the most proudest of this part of my van, although it's not something that you really see, it's in the back. But we're really going to talk about the safety features and why I chose to build this out of aluminum and the structure that I did, the way that I did to house all of my main electrical components, and let's call it the battery house where I store all my energy at. The great thing about this as well is with the 80/20 product, which we're going to talk about, just for the frame itself, not all the add-ons, you're looking at about $350. And if you stick around to the end of the video, we'll tell you a way that you could build this thing for under $200. There's another alternative out there, but I love the 80/20 product. So let's get going. This is what I refer to my battery bank, my battery house. There's a lot to unpack in this, and we're going to cover a lot of this in the electrical section. But really what I did is I wanted to build a frame that I knew that was secure, and that I wanted to make sure that these batteries were going to be staying in place in the event of a serious accident, whether that's a rollover or whatever. I just have a hard time thinking about the amount of weight that's in this, and then there's some type of situation where these things start flying around the van. So I really built this to be able to expand out to 400 hours of lithium ion. Here we have three 100 amp hour batteries, and these are light blue, and we'll talk about that more later. And then also here we have our 4,000 watt inverter. I have this breaker box, which I really don't need because the inverter has breakers on it, but we'll talk about that later. So this area here was built for a fourth battery in the event that I needed it. Also looking at the side profile, we have my charge controller here. I have my 12 volt electrical outlet for my air compressor, because I do take this out onto the beach and I do have to decrease my air tire pressure down to 15 to 18 pounds. So I need a way to pump up those tires when I'm done. But again, this is my 12 volt electrical. This is my 110 that runs off of my inverter, which is converted from the electrical here. This is where we have all the electrical coming in from the alternator, where all the batteries are connected and all the leads are running back to the other two fuse boxes that I have in the van. I also had the ability to mount in mounting strips, because I do haul a lot of stuff around in my van. My van is an adventure van. I also had the ability to put these rings on here that are removable, so I can put my tie down straps. I have tons of D rings on this thing, so anyway, you needed something super, super heavy duty, and this is what I made. So let's get into the detail. So this is really the frame that I built. This is about 48 inches wide this way. It's approximately 25 inches high and about 13 inches deep. These are rough estimates. So when you look at this frame, I calculated I needed about 560 inches or 8 6-foot sections of 80/20 to build this frame out, okay? And as I said here, and then over here is where we're going to mount the inverter, so we'll get into all that, which is right here. But this is the frame structure that we're going to be talking about today and how we built it. So a lot of information here. 80/20 was the product that I chose to make my items out of here. If you take a picture of this QR code right here, this QR code is going to take you to 80/20's catalog, as well as 80/20 University. I don't want to spend too much time in this video going over how to build a frame, but I'll just go over some of the components that I used. Number one, this is the 80/20 frame structure here. This is 10 series, which I used. which means it's 1 linear inch from here so it's a 1 by 1. And in the center hole here, this has the ability to be tapped out for a 1/4-20 bolt. There are 3 or 4, there's actually a lot of type of fasteners, but the primary fasteners that I used in my build for this cabinet was the slide-in T-nut, the roll-in T-nut, then this is the end fastener right here, and then there's three tools that you'll need when you're doing this. This is a tap that you'll need to do to thread this end, and this is an access hole drill guide, which will allow you to drill holes into this cleanly. Let me move out of the way real quick. These are the different types of profiles that are available through 80/20. As you can see here, these have 4 slots on it, and that's what you would need for this project. But they do make other profiles where there's only 1 T-slot, 3 ends are finished, 2, the top and the right are done, and then these 2, then you have 3 with 1 finished, and so on. These are the different profiles that are available from 80/20, and you can make just about anything out of this that you want. And that's why I love the product and I use it for the van. So I highly encourage you to take a look at the QR code and go to the site. There will also be a link in the description to the 80/20 website. So as I said, when you looked at the frame structure, the majority of what I did with this build is I used these standard end fasteners. And this is the product part number right here. And really what it requires you to do is to use this access hole drill jig to be able to identify where the hole is so that you can drill through this accurately and then line it up to the center of this and be able to take an Allen wrench and tighten up this screw. So let's talk about how that's done. What I love about this product is it's very easy to work with. It cuts easily with a circular saw, 60-tooth carbide, very clean cuts. But you have to wear the safety glasses because there is a lot of aluminum shards coming out. But it's very easy to cut. The other thing that you're going to need to do is in the end of the 80/20, you're going to have to tap in a 1/4-20 thread so that we can screw those fasteners in there. And that's also easy by just I used a simple vise. This is the 15 series, but it's the same thing. You use the tap that I identified, take some threading fluid, and all you're going to do is drill this hole and screw this in. It's that simple. So on this project, you're going to need to tap about, I calculated, 42 holes. But again, if you look at it, it only takes a few seconds to do it. It'll give you a solid structure for you able to build your battery frame with. So as I said, all you need to do is this is the jig. And what you have to do is identify how high you want your frames to be within your battery box. And then you mark this. So really, it's just marking a lot of this stuff out with a ruler, taking the jig, lining it up with the pencil mark, drilling a hole all the way through, and you're done. It's that easy. Then you can see this is taking it and it goes straight through. The drill will go straight through. This is not the tap. This is just a drill. And this is really here for one reason and one reason only. It's to be able to take your Allen wrench through it. So as I said, this guide will create the hole. This, now that we've tapped the end of the 80/20, this threads into here. And all you're doing is you're taking your Allen wrench, going through the hole, across here and tightening into this. And then you're going to do the same thing going through the other side. And then you're going to start to get your frame like this. So let's go over this again. So here you would drill a hole going up and down and front to back. This would require 2 holes drilled. This would only require 1 hole drill, 1 hole, 1 hole. And then each ends where the thread is going to go, that's got to be threaded. So like I said, I've calculated this out to be about 8 pieces of 6-foot 80-20 aluminum, and approximately 42, sorry, I'm looking down, about 42 of the anchors to tie this whole thing together. The other thing that I did, as I mentioned, my inverter, I wanted to be able to mount to this frame as well and make sure that it does not move. So what I did here is I marked where the holes were on the inverter and I lined up my threaded studs. So two things to remember. These are automotive threaded studs. Link is in the description. This is 1/4 thread going into this slotted T-nut. You tighten that down. And then on top of this is 1/4 and I also have a link in the description for some nuts for that. You can use whatever thread you want. But the T-nuts, the T-slot, these are 1/4 unless you get the metric version of this product, okay? And then that's how you would mount that. This isn't going anywhere. This thing is solidly built. The next thing I did is this is the 1/4, this is the 1/4. So this is 20 threads per inch. This is 28 threads per inch. So this is a finer thread. So this is what's going to screw into the frame. And then the nuts and the washers will hold the inverter on with that. And again, just to show it here, this is what it would look like when it's done. Okay. The other thing important to note is I also mounted in these angle brackets, and these angle brackets are going to help me bolt this to the floor, to the wall, along the top of this. This actually gets bolted in to the rivet nuts that I put into the side wall of the van. All this stuff was laid out initially. So like I said, there's a lot of planning behind this, but this is all easy to do. It just takes some time and some patience. So here we have the frame just roughed in place. Inverter is mounted, and here are my batteries. I could have easily taken this and made it narrower if I wanted to, but I wanted to have the option to go up to 400 amp hour batteries in the event that I wanted to put an air conditioner in. Here we have the batteries. Now the next step was, how do we create a frame that's going to keep these batteries from shaking? And then how do we create some type of fastener to bolt and to mount these in? The next thing that I did is I took a simple, this is 3/4 by I think 1.5 inch frame. And then I just glued and screwed this together. And as you can see, each one of these have their own little tray that they can sit in. The next thing that I did is I took a ratchet strap along with a board. I mounted the ratchet strap with a T-nut and bolted the ratchet strap to the frame here. And then I bolted the other side to the wooden base. And then this is how I ratchet down my batteries. These are not going anywhere. Put this next plate in here. All I did was, this is a 1/2 inch plywood. I took some aluminum strips and then I screwed it to the floor and I screwed it to the top. And now I started to connect my batteries. Over here, we'll get into this in the electrical section. Let me move out of the way. On this section, you'll see that I also brought in my solar connectors. So this is where my solar's coming in. I have 2 breakers here from my negative and my positive going to my charge controller so that I can still have power going to my charge controller, but not have it going to my battery. So there's a lot of different things that I did. I had an electrician help me with some of this stuff. This is the only part where I got help was really on my alternator, but we'll talk about that further detail. On the side of my battery frame, I wanted to mount my charge controller. So all I took here was another 80-20 piece going across, and I took another piece going down. This is just 1/4 inch plywood that fits within the slot. I wanted to keep my van stealth, so I didn't want really any electrical connections, water connections, anything on the outside of my van. So I just mounted this other 110 outlet on the back of the van in the event that I need it. And as I said here, I put all these D-ring fasteners here because I do use this frame as a tie down for any of the material that I have in the back of my van. From the side view here, the other thing that I did is I put in a Lexan polycarbonate cover over this. I just didn't want anything banging into this. These are all on magnets. So what I'm able to do here is I only have this main switch to turn on and off my inverter. If I don't use the inverter, my house switch is turned off. So this inverter is not drawing down on my battery bank. If you leave the inverter on, it will draw down your battery bank. And then we'll get into more of the discussions around that with the electrical components. And then here you can see I have this wire tied up. This wire here is for me to be able to charge it, plug in. So even if I'm at a campground, a friend's house, anything, I can plug this in. I installed this years ago. I have never, ever plugged this in. So here it sits and never needed it because I have solar and alternator charging to my batteries bank. This main line, this is a 0 cable coming in. This is my positive coming in from my alternator. So this is my fuse to the alternator in the event that I have a problem. It blows that fuse out. Then this also comes, I have a fuse coming in from the inverter. So, and like I said, when this is turned off, I am then no longer drawing from the battery going to the inverter, but we'll get into that later on. These are, I run Cat 5 extra. These are my controllers. This is the wired connection to my inverter, and we'll get into all that later on in the detail. But like I said, I put these heavy duty magnets on here, and this polycarbonate Lexan shield goes up. What I'd want to talk about is the 80/20 alternative. 80/20, like I said, I am a huge fan of this company. I've been with them using their products for a long time, but their connectors get to be very, very expensive. So what I started doing was just trying to find another source for the connectors. And I would take a look at this company called T-Nuts. They're a slotted aluminum hardware company. Shoot the QR code, and a link is also in the description. But I did a price comparison of all the components that I needed for 80/20. I calculated out that, like I said, you need about 8 6-foot sections of the 1-inch profile. And if you get that from 80/20 without shipping, that's about $240. And T-Nuts is only $132 for all the aluminum at today's pricing, right? Pricing's going, it's crazy lately. And then when you looked at the connectors from 80/20 are running about $90, where T-Nuts is about $62. The price comparison at the timing of this video is the 80/20 product would run you about $350 to build this aluminum frame, where the T-Nuts would run you about $199 or $194. Huge difference. And as we get into this further, you'll see I used 80/20 throughout my entire van build. So when we start talking about how much does it cost to build a cabinet, big differences. So you go to RB Components and you look at what they're charging for these cabinets, it's significant. And I personally don't want to put wood cabinets in my van. You get into an accident or something happens, do you want this stuff flying around? So again, that's why I chose to use aluminum profile when I built my cabinets out in a lot of my structures. So we're going to get that into future videos. Please, any questions, comments, please list it below. If you guys want other videos on how I actually connected this stuff, I can do that. But like I said, all this stuff is available, the information through 80/20 University. They have all these instructions. These guys are professionals. I'm just the van guy, right? So So they would be able to provide you more information. So thank you very much for watching. Again, we have a series of 22 videos. They're all linked in the description. Please subscribe if you want to see future videos. Thank you very much for watching, and we'll see you on the next one. Take care.